Cool. So, what do we remember about the React Lifecycle methods we talked about yesterday? Anybody? Just like what are they about, and why do we want to use them? Okay. So yes, components have sort of like phases. What are the phases that we saw? Mounting, updating, and unmounting. What are some of the functions or those lifecycle methods that are run on the mounting phase? Yes, Suzanne.
Component did mount.
Component did mount. Anything else? This one is the last one that happens in the. So we saw that yes, these are the phases, but within these phases we also have like sort of like an. I think we call it. So there were these phases in the graph that we saw yesterday were like the horizontal axis, and the vertical axis we had like the render phase and the commit phase, right? So it's sort of like. And then we saw that the component mount is the last thing that happens, I think, from the mounting phase. What are the things that happen before component mount that are still part of the mounting phase? Constructor. And I think there's another one. Then the right. These functions, these methods get called on the mounting phase, and the order is the constructor always happens first. The second is the render, and the third one is the component mount. Sort of the end of the mounting phase is sort of we know that once we reach the component mount. Somebody else, maybe the updating phase. What are some of the functions that run here?
Component did update.
Component did update. And I think component did update. And is there any other one in this? Yeah, John.
What about the virtual DOM, the React DOM?
Mm-hmm.
That phase? Isn't that also in the mounting phase?
Oh, well, but that wouldn't be called like a lifecycle method. You mean like the first? That would be basically the first thing that happens when you call React DOM that render. Is that what you're talking about? Like in the index.js file. And what is the other thing that happens on the updating? That is also part of the mounting phase. Render. How do we get a component to be on this phase, on the updating phase? that component to be in the updating state, on the updating phase.
Oh, you have to use, you set the state and then it renders, or you render and then it sets the state.
Right, that's correct. So setting the state is a way in which you sort of get the component to be in this phase of updating. We know that after the updating, after a set state, like that diagram explains it like in the correct time frame. But after a set state, what happens is that the component renders again with the new state, or as a consequence of setting the state, renders gets called again, and then after we get that new render, we get this function fire component did update, sort of like notifying the component did update. And then unmounting, we have one. Maybe, I mean, which one is the method that runs on the unmounting phase? Is that correct? Who can support? I mean, component is it component the unmount? Will unmount. The component can notify like this is sort of the component. This also sometimes these functions are known as like hooks or lifecycle hooks, where hook is just like another word that you can use for like I'm trying to just like remember. So like these are things that React is executing when it's mounting components, when it's updating components, and when it's unmounting components. And in those, you may want to like get hooked onto one of them to do any additional work, like cancel the network request, or making the network request as soon as the component mounts. Cool. So these are basically the major ones. Then there is should component update. Get the right state from props that are more rare, but you should still just sort of be aware of it. And a way that you can think of it is once you're creating React apps, if you start to see that you're having trouble, like there is some functionality that you want to implement and you're having trouble adapting it to like the lifecycle methods that we have, then once you realize that you have a situation like that, you can start looking into those more advanced React lifecycle methods that could have the mechanism for whatever is more advanced that you need to do. What was that? Oh, that's a cool game. I played that game when I was a kid, and I just remembered it today. Everyone seen that game? I think it will be a fun project to create in React. This game. So it's lottery basically, but with images. And you have to. Oh yeah, this is. It's like bingo, yeah. But just with images, and you sort of say which one you have, and you mark the one that you have, and then this is like multiplayer, and whoever is like the first one to like cover all their images. In this case, it seems that with beans, then they win basically. So it is like bingo. I think. Yeah. So I think this will be a good project if anyone wants to like practice their React skills. This project will be cool. I remember I did a game. This what is it called? Like memory, that where you have to turn in the pairs. I think I didn't style it that much, but this is like another idea that. What is it called? Concentration. This is like a a small React game where you basically have just to match the pairs, and it was a really good challenge, especially because I wanted to, whenever you click, you can click two cars, you can reveal two cars, but when you click a third one, I wanted the two to go back to the original, to like be turned back. Oh, I guess it's broken and I haven't checked it in a long time. Yeah, I'll have to show you another time. But it's basically like this, and you have to just find whatever the two things are. The good challenge was also how to like randomize it, because I don't want all the images to be always in the same place. And yeah, cool. So going back to the lifecycle, I just wanted to show you this other example for us to solidify that. Code. Npm start. Let me share out this. Live. Let me share this link so that you can connect to my VS Code and oh, it seems that Amin made one. Let's check Amin's game. So there's some cars here. So it's basically this game. I mean, you do this with plain HTML or you're using React? Cool. It'll be cool, like if you want to translate it to React, to sort of see it, compare it to, yeah, it's basically this game. I think what I didn't want was like this, that I can see basically 4 images at a time. That was something that you could think about, like how when the user clicks the third image, you want to turn the others back on. Because here, if I'm fast enough, I could like look at a lot of images, right? But you know, this is a pretty good MVP though. Good job there. Cool. The screen is broken. Oh. Wait, the stream? So cool. So could people connect to my VS Code with this link? Cool. I see some of you already are joining. So on this, actually, I want you to take a look. Let's say like 5 minutes. Take a look at around this project. It basically only has 3 files: index.js, greeting.js, greeting container.js. So just take a look around. Maybe look at the lifecycle methods that we have implemented. Maybe if you have any questions about any of the code that is there, raise your hand and ask.
Can you explain bind again?
Yeah, I forgot to share that link yesterday. Let me just share the link first, and then I can walk again. Cool. Any questions about the code that you saw there? About maybe what that will look like in the page. So let me show you here what that looks like in the page. So basically we have this this is like more than a useful application, is to demonstrate the lifecycle methods. But here we have this thing that we call a greeting. The hello, the add exclamation point or remove exclamation point. And if we click add exclamation point, then the exclamation point is added, remove, is removed. Now this plus here is, let's say we want to have multiple of these greetings. So if I click on plus, I get another one, right? And that is independent of the first one. I can add another one, and so on. So what we want to explore here is what happens when I click plus, what happens when I click updating one, what happens when we click on minus, and the minus will remove the last one, and what are the lifecycle method, what is the lifecycle of these components basically. So let's start back from here. Oh, just sort of to touch here on bind again. This is how we used to have to do functions that we wanted to invoke as event listeners on our React components. We have to bind them like this, saying this.add bang, and note that all of this is in the constructor. So right after the state, we will say something like this.add bang equal to this.add bang that bind this. And that article that I shared explains the why a little bit better than I could possibly do it here on the time we have. But what happens is that when we have a function like add bang, this function is part of the class, it's part of the component, right? So it knows what this is. It knows what this is if I say yeah, I think the explanation can get into the weeds. So, but what the problem is at this point, or the problem is the way in which we use this function. The add bang function, we don't use it sort of attached to the component. We pass this function, like the add bang will pass to an onclick. Like if we look at here, the button has an onclick to this.add bang. The problem is that when we're passing this function to the button, we lose the this. We lose the this. And that resource that I shared shows an example of why it's lost. So we need the this. We need the this to be able to update the state, and that's why we needed to bind it. Binding is sort of recovering that this, or rather explicitly binding that function to have a this that refers to the component. This, like in this case, here, functions have like a default binding. So by default, they will get a this depending on where they're written. If they're written inside of a class, the this will refer to the class. If it's written like in the global scope, the this will be the window object or the global scope. And the problem again here is that we lose that once we pass it to, because in here we're passing it sort of as a callback to the on-change event listener. We lose the this, and we can't lose the this because we need that function to update the state, which refers to the class. So that is sort of like a very quick explanation. But yes, you want to like dig deeper into that. That article explains really well. And maybe later on we could do like a more in-depth review of bind and what goes on when you pass a function as a callback and how you lose this keywords. But lucky for us, then ES6 arrow functions came. And arrow functions, a feature of arrow functions is they don't have their own this as regular functions. They bind what is known as a lexical binding, but what that means is that arrow functions will take the this of the scope they're in and bind automatically to the this of the scope they're in. In this case, the scope that this function is in is, or the this is the greeting class, the greeting component, and it automatically binds to that. No matter if we pass it as a callback, the arrow function will not lose the this, what this means. An example of like if we don't have this binding here, for instance, if we have this ES5 function here, if we remove this the binding here, then we get an error saying that this is undefined. In our case, let's actually look at that. I think it was to the add bang. Was it? Yeah. When I click on the add bang, we get this error: cannot set property set of undefined, because that function, this function, add bang, I'm not binding at the top. It's not an ES6, so it loses the this. It just completely forgets what this is, and we want this. The this keyword to point to the component, to point to the class. Therefore, we need to bind it, or we need to use ES6 format that save us from the binding, thanks to the lexical binding feature they have. Cool. So let me just do that there. There is no like. I would say there's no preferred way. You could do like both are fine. I do feel that like the just taking advantage of the lexical binding of ES6 is just better because you avoid this repetition here. But I think you will see both like in React tutorials. So it is good to be able to understand how both work. Cool. So let's look at the life cycle that we have here. So we basically have something like this. We have a greeting container, which is like our main component, and we have greeting individual single components. In this case, we start with just one. We start with one, and just we have the buttons sort of independent, as we can see the greeting container here. It's a constructor, and here. We have our buttons here that have an on-click to add greeting and remove greeting. And we have this function, we're calling this function here, this.render greetings. What this function is going to do, if we go to the render, to where that function is, which is here at the top, render greetings. What this function is doing is we basically, in our state, let's start with our state. This is our greeting container, this is our main component. In here we have greetings number. So this is basically showing how many greetings are we showing. And remember that a greeting is like this hello world with these two buttons. So here we have one greeting, here we have two greetings. Here we have two greetings, 3, and this number is just going up in our state. Now what we want to do is we want to have 3 greeting components. So what this function does, the render greetings, is just looping from 0 to 4 or whatever number greeting numbers is. And we have a greetings component array that starts empty, and we push a greeting single component to that array, and then we give that array of greeting components to React to show basically multiple of them, as many as we click the plus button. So let's look at, or any questions up until this point? We start with 1. So let's look at here. We have the first, this is sort of like the same that we were doing yesterday. The first thing that happens is the greeting constructor container, or the greeting container constructor gets called, because that's the parent component. So this one was created basically. Once the constructor is called, the component is created. Then we see the next thing is the greeting container render is called. And then after that we see greeting component A constructor call. And this greeting component A is this first one. So we're gonna like enumerate this, not really enumerate, I guess you would call it, just label it. So this is like the first greeting component is, we call it component A, greeting component A. And once we create another one, we're gonna see greeting component or component B. That's so that we don't get like lost in these console logs. So going back here, first thing that happens is the constructor in the parent gets called, the render in the parent gets called. Since the child is being invoked in the render of the parent, then we need to create the child, right? Which is the greeting, and that's the one we call. So after the render is calling is invoking the child component, and then we see greeting component A, which is this one. Constructor was called, then the render of this component was called. Then once the render is called, the user will see it in the screen. And the last thing that happens after is render. We see greeting component mounted. Right? And the last thing that happens is that the greeting container finished mounting. Right? I said yesterday how the parent won't finish mounting until all its children are mounted. Right? So that's why we see that this one mounts first, and then this one. Cool. So any questions up until this point about sort of the flow of, basically we're seeing this where the mounting phase, where we see the constructors happening, the renders happening, and the component mount happening in this order. The constructor first, the render second, the component mount third. So, any questions up until that point? Yes, do us.
Will children and children render before children?
Yes, children of children will render before children. So you mean like grandchildren will render and be mounted before the children, yes. Mm-hmm. It goes like, if Greeting had a child here, then the constructor gets called here, then the render gets called here, the render calls the children constructor runs, the render of these children calls this one, the one on the, calls sort of the constructor on the grandchild. That one renders, that one mounts, then the parent of this one mounts, and finally the parent of them all finish mounting. So it goes, yes, it kind of goes deep, and it comes back up, sort of. Other questions? So let's look at the updating. So when I click on this plus, what happens is that on the parent, we're setting the state to be from 1, basically just incrementing a counter from 1 to 2, which is this counter that we call greeting container. Greetings number. This is how many greetings we are displaying in the screen. And the plus button, what it's doing is just increasing that. So when I click on plus, what we see is, so note here that this console log sort of marks the end of the mounting phase. And then after that, we get this. We get since we set the state, the next thing is a render. We see that the parent renders. Then, because the parent render, and now we have a new child, but the parent renders again. Then we have that component A, this one, the one that we created first, gets rendered again. Then after this one gets rendered again, we see that the component now B, which is this second one, gets created, the constructor gets called, the render on this one gets called, the component did mount on that one gets called, as we see here. Oh, wait. We have this one updating on the fine. Let me just, this console log here is the one that I'm not sure. Component did update. Anyway, let's ignore this console log for now. Once we have this, let's mark this one as, this is greeting A, this is greeting B. Let's start from scratch again. So we start with 1, we add a new one. Then we see that the constructor on the B1 is called. Then the render is called on B. Greeting A is being updated for some reason that we can discover later. And the last thing that happens with B is that B ends mounting. And now we see that the last thing that happens is that the greeting container, meaning this one, component did update fired, and we got this message here. Greeting container updated now with 2 greetings because it finished updating the state of, or finished updating the state and re-rendering, meaning, and we could refer that as just it finished updating, and the component did update got fired, and we see this console log here. Once the greetings now passes from 1 to 2. And let's add one more time, and we're just gonna see sort of the same stuff happening. So this was the last one that we saw. Then we know that once we set the state, render is the first thing that happens. After that, the component A re-renders. Note that component A was not created again, was not created from scratch. The constructor on component A, when I added that third one, was not created again. It just re-rendered. Then component B is re-rendered. Then component C is created. Then the render on C is created. The render on C is called. We see that A and B are updating. Oh, actually, we know why these are happening. If we go back to the graph that we were looking at yesterday, we see that our render can happen because of a set state or because new props are coming in, right? In this case, this is what's going on, these new props. What we have here that when we create a third component that we call C, what happens is we see that that A and B re-render. They were not recreated. The constructor was not called again. They got re-rendered. Then C was created. Then C was rendered. After that, we see A and B are being updated. These are console logs coming from the component did update, and that is because they are receiving new props. Because I'm passing props to these components here. As we look at here, we're passing in an ID. This ID, what it's doing is just taking in, is creating that letter, this letter that we say A and B. We can use this function like string from char code that basically, if we go back to the idea that computers only understands numbers, letters are also actually numbers that you ask the computer, I don't want to see this data, this number, as a number, I want to see it as a character, and then it shows you a character instead of a number. There are some mappings that are, there is ASCII and Unicode, and basically like if you look at the ASCII table, and Unicode is an extension of ASCII, but if you look at an ASCII table, you can see sort of like the numbers. You can find out what letters are what numbers. So if we look at like A, for instance, an A for a computer is not actually an A. An A is a 65, and a B is a 66. It's just that instead of you could sort of ask the computer, don't show me the 65. I want the letter. That is then it's gonna give you A. And that's what this is doing basically. So we know that 65 is A, and I starts at 0. So the first one that it's gonna give me is gonna be A, and so on. And I just use that as an identifier for creating these A, B, and C, so that we could see it. But here then, these are just props that we're passing, and whenever the component receives new props, even if they are actually, even if the props have the same values, the component will re-render. And that's why we have this lifecycle method, or one of the advanced ones called should component update. Should component update, I think is if you go to the documentation, it says should component update should be used for like performance optimization, where you don't want stuff to re-render if nothing has changed, right? Like you don't want stuff to re-render if nothing has changed to display something new to the user, basically. Cool. So we see that once we create C, the constructor is called, the render gets called, A and B are re-rendered. The ingredient component C is mounted, which is this one. And once this one's finished mounting, then we get the container finally finished update. Now we have this console log. Remember that this console log is coming from a component did update on the container, on the greeting container, which now finished updating with 3. And then now let's look what happens when we remove one. So I'm going to remove, now the counter is going to go from like 3 to 2. And we saw that this was the last one. Then what happens is we're setting the state in the greeting container. Render gets called in the greeting container. We see that render gets called on A and B because they receive new props. Then we see greeting component C about to unmount with message hello. And then we see component A and B being updated. And finally, the greeting container updates with 2 greetings. But here, this message is coming from the component will unmount, which is sort of what I explained yesterday when React sees that the virtual DOM and the actual DOM, and is going to compare them, and it sees that one component should not be there anymore, then it calls the component will unmount for you to do any cleanup work, etc. Cool. So any final questions? I think I'm gonna put this in a repo for you to inspect. But any questions regarding sort of the sequence of steps that happen? Cool, so let's do, I'm going to put this on a repo and then I can share it for you to inspect it further. One thing that here I wanted to jump in quickly is to this fact that when I create a component C, let's go back here. We create component B is mounted. The last thing that happens is that the greeting finished updating. When we mount a component C, for instance, component A is updated, component B is updated, which is weird, and we see that the render on component A and B get called, even though those components didn't really change. We didn't change anything on them. So this is where we could implement should component update. That we could check if the props have not changed, then don't update the component. And I think I have it here where if we go to greeting, we have this one commented out here. So let's look what happens when we uncomment that. It says should component update. This should component update is just going to check if the props have changed, if the value of the props have changed. In this case, if this component, for instance, received a new ID, then that means that the component has changed. Then that means that we'll probably want to display something differently to the user. But if they haven't changed, we want to return the next props. Otherwise, return false to prevent the component from re-rendering. But again, this is sort of for a small performance improvement. And as I do that, once I add one, we see that, let's add one more time. We see that we added component C. I know that component component A didn't re-render and component B didn't re-render. In fact, they shouldn't re-render because they have the same props. If they receive new props, but those haven't changed, those are the same. And in this case, they don't re-render. If you're creating components that you want that you don't want to re-render when they receive new props and those new props haven't changed, you could implement should component update. Or what you could also do is instead of extending from React component, you could extend from React pure component. If you inherit from React pure component, we see the same behavior basically, because React pure component is just a component. The only difference is between the regular component is that it implements should component update for you. So it internally checks if the props have changed. It's gonna re-render. If the props haven't changed, don't re-render, because why re-render if we could say that step, meaning nothing has changed. That's sort of like a small note there. Cool. So any final questions before we move on to the lab about lifecycle methods in general? They are quite tricky, at least at the beginning, and you sort of don't really like. I can explain it a million times, but it's sort of like something that you develop as you start to use them, and as you start to feel the need for them. The ones that we're going to be using the most are component did mount and component will unmount, basically. Cool. So, no final questions? Okay, so let's move on to the lab. So for the lab, what we want you to do is, let's go to Canvas. We want you to build a small to-do app, basically, like this one, with React. And what we want you to have is display when a new to-do is added, you want to display this notification that is popping up here on the right. The good thing is you don't have to implement these notifications yourself. There is a package here that we want you to explore, which is called React Toastify, that will allow you to have those notifications. But what you have to figure out is basically how do you have it so that when you create the to-do to show the notification, and when you delete the to-do, this here, you created a to-do, then that one come up. You create another to-do, then a new one comes up. Once you want to delete a to-do, the notification for deleting also happens. And we want you to use lifecycle methods to implement that, basically. Oops, where did I go? You will end up with a component tree that looks like something like this, where you have a main component, you have the form, which is where the user is going to type, and you can have a to-do list. This to-do list could be a UL or OL that basically just iterate over your to-dos, and for each one it creates a to-do item. And that's pretty much it. This, as I said here in the README, we shouldn't need a submit button here or a send button. It should work when you hit enter. The form should be submitted. Cool. Any questions about the lab? Cool. let's get to work. Make sure that you're asking your questions. Give me one sec.